Sorry. I'm live. Okay, let me open the chat. Chat. Just a minute. Hopefully, yeah, I got the notification. Cool. So today we'll try Leetcode and then some of few Leetcode questions and few Edcode questions. So audible, and right? Then some of few yeah, that's fine. So I have solved few questions actually. It's a bi-weekly or the weekly? Let me check. Let me check quickly. Okay, so I haven't solved any bi-weekly question. That's good. I can try. And I have solved. As I remember, I solved. This question is solved, right? Okay, so this has. I've solved two questions bi-weekly. Okay, so I can start. It's three medium question, right? I already solved two of them. Here we have. This is bi-weekly. Here we have two medium questions. That means we have three medium questions. Hard, I don't know I'm able to solve or not, but medium at least we can try. Should I try this or should I try this? Try it easy. Okay, let me try this first and then we'll move to next contest. Shortest path with at most k consecutive identical character. Okay. It seems like in graph question. Yes. We are given an integer n representing the number of nodes in a directed weighted graph. Okay. Numbered from 0 to n minus 1. This is represented by 2D integer. Okay. V1 to U1. There is edge from V to U with weight this. Okay. You're also given a string called label of length and where label of I is the character assigned to the ith node and on integer and an integer k. Okay, so this is our input. What we have to return? Return the minimum total edge weight of path from node 0 to node n minus 1 such that it concatenate of the labels. Okay, such that if you concatenate of the labels of the node along the path that contain at most k consecutive identical character. If no valid path exists, return minus 1. Cool, cool, cool. So it seems to, let me just revisit the constraint. K is 50, that's fine. Weight is also 10 to the power 4, and age is 10 to the power 4. Okay. So it seems to a Dijkstra, yeah, uh, yeah, it's a Dijkstra algorithm. Yeah, I feel because we have to maintain the minimum weight, and one more condition is this. We have to maintain a queue actually. Yeah, the queue will be a minimum. We can maintain a queue like we want minimum weight, right? So we will maintain a priority queue, mean priority queue. Yeah, that's it. And we also maintain the count of consecutive characters. It should not exceed k. Cool, cool, cool. So firstly, we have to create an existency list. Let's do that. Vector of vector in existency list of n. Now we'll iterate auto. It's a vector, right? So auto ampersand x over edge. Actually, I'm just trying to create an adjacency list. So what is u? U is just x of 0. What is v? V is just x of 1. And what is W? W is just an x of q. So it's actually vector of where int comma int. Okay, so we have to push existence list of view dot push back a pair that is v comma w. Yes. Now we have an existence list. We have to maintain a priority queue, a mean priority queue, right? Priority queue of int comma. I have forgotten. This is by default. It's the mean priority queue, right? By default, it's the mean priority queue C plus plus. By default, it's a max priority queue, I think. Yeah, by default, it's a max. We want a mean priority queue. It's just a vector of int. As I remember, we can do like vector of it's a pair actually. Wait, what we are going to save in our priority? We want a minimum priority queue based the what is the minimum criteria here is the weight because that is what we have to minimize here. And what else? Actually, we have to store three things: weight, node, and the number of consecutive this. So it should be a tuple, but I don't know the syntax of tuple, so I can do like this. And then it's this, and there's called greater something of this. I think this is the syntax if I'm not wrong. Let me first compile and see if we're getting any compilation error. Yeah, we are. V is okay, there's a spelling mistake. Okay, cool. No, let me see the syntax then. What's the mean priority queue syntax? Yeah, this is what we have to. This is what I'm trying actually. What I did, let me just verify quickly. Greater, yes, int vector. This is the data type I want to store. Then a vector. Yeah, this is the vector and the greater. Yeah, then what's the issue? I think the priority, there's spelling mistake. Oh, yes, this is fine. Now we have mean priority queue. Mean priority queue mean based on first weight, and this is the only priority, and rest is yeah. Now what we'll do here is we'll create a vector of wait a minute, 10 to the power 4, right? And let me create long distance n comma 1e9. Okay, cool. So what we have to distance of 0, we have to mark it 0 and dot push back. Yeah, we have to reach from 0 to this. Distance of 0 is 0, and what we have to do is we have to push. Uh, till now we have 0 weight because this is starting position. This is weight. This is the let me see. Let me mention here. We are storing weight, node, and number of consecutive identical character. This I'm too lazy. I will not write out the things. That's fine. So this, and number of consecutive characters also zero, right? While, while q dot not empty will do this. What we'll do here is we'll take out the element, right? That is the u for us. The u will be pq. Let me first do this thing. Auto top. Let me just quickly yes. And now I can read the chat. Hi bro, how are you? So where we are? So top element, right? So what I'll do is auto temp is equal to pq dot top and pq dot pop, right? So what we'll do here is, yeah, so u is equal to tm. This is our node, right? That is weight node, and we want this element. So what we'll do is this is pair. This is its first element, and this is a second element. How we'll access this whole part is temp dot second. Now from this second we want this part. So that is dot first. Okay, this is our U. Then what is our weight? Weight is just the first part. First is our weight, right? So just tm dot first. Okay, and number of consecutive character that we can count. Let's say count is equal to this thing. So that is just tm second. It's a sec. This is second, and the second of second is the count of consecutive character. So just a tm dot second dot second. Okay, now we have everything. So what we'll do is now we will explore this parent, how many children it is connected with it. So what we'll do is we'll iterate through its adjacency list. Okay. Do we need to maintain a visited here? Let me think for a while because we are maintaining queue, right? I can ask you a question here. It's basic, but it's fine if it is. No, no, you can ask. It's fine. I'm not. It's not a live contest. I'm just practicing. It's fine. It's completely okay to share. That's how you can grow. That's how we are growing. Right. So let me not think about much. So what we'll do is we'll iterate through child of it's this friend, this use child, this you, it's children's, right? So what we'll do is we need a visited. Actually, I think we need visited. Maybe we need visited, right? Or not. Firstly, what we have to chew here is this. Uh, if distance, this is the current cost. Wait, if it is not visited, I think let me just do visited. If it is redundant also, then also it's fine. Everything is not visited, then visited of zero is one. Okay. What we'll do is if it is not visited, this children, and what we'll do is now if distance, so w plus, and how can I get the distance? We are storing here, right? V, and this is the w. So it's like a and child dot first. It's a v, right? This is the v we want to access. It should be child dot first and w plus child dot second is less than distance of this. Then we are going to visit and one more condition, number of character. Also we have to check number of character, right? And how we can check that is okay. So instead of now we want which character its parent has, right? Yeah. So we count here. Current count. Current count is zero. It's actually count. And if parent, that is you, what we can do is we can recalculate here for each child. We can do is, let me just declare this is fixed for each child. If label, where is label? Label. Yeah, a label of instead of writing this, let me write this. That will be good visibility. Code readability is good actually. It's not confusing. So V and the weight, it's fine. This V. Oh, I had a question, right? I'm entering my second year and I want to start BSA. I did for a dev, but not too much. I'm choosing CPP, so I'm a late to. Arey, bro, you are not late actually. I also started in my second year of BTech only. Yeah, it's not too late. It's fine. You can start actually. Actually, what I'm saying is, if you start, it's not too late also, and it's not too early also. It's the right time to start. Yeah. So label of V is equal to label of U. Then we have to increase the count, current count, and current count should less than equal to K. Then we have to push this PQ dot push back. So how many things we are pushing is first is weight, that means a new weight. This is the new weight. Let me declare a variable. New weight is equal to this. It's a good start, bro. You can start actually DS. It's not too late also. Actually, it's the right time to start because in the first year you just gain basic fundamentals of C++. I know it was a dumb. No, no. Who said it's dumb? It's a great question actually. And if you come up with such question, that means you are in the right track because most of the people don't even think about in second year. Right? Don't feel dumb. While asking question, never feel dumb. So yeah, what we are pushing here is weight, right? New weight. Then the second is node, that is V, and that is consecutive character. This. Oh, but the thing is, yeah, this is fine, right? Yeah. And also we have to update distance of S of V is equal to new weight. Cool. And when we gonna break this, and I think I'm not sure, n minus one. Let me test. It's gonna be infinite, right? Okay. Oh, it's just a push. Actually, it's not push back. What the hell? Okay, I got it. It should be this, I guess. Yeah. Okay. Dun 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 dun. It's a this. It's a this. Cool. So something is fine. Why we always getting two? Why we always getting two here? Why my output is always two? I have to check here. And answer is equal to. I think it's something big. Let me give it 118. If this of n minus 1 is equal to 118, then return minus 1. Why? Why I'm getting 2 always? I think I missed something. If this of v is less than w, then continue. Okay, we have to run a pure extra here. It's a u. No, it's not u actually. This is how we run extra, right? We maintain a mean priority queue. Yes. Why I'm getting 2 here? Wait. Let me debug this. K is equal to 1. That means, okay, it's a 1. Then this, okay. So by default, it's a 1. Okay, got it. So we are pushing, right? The number of packets by default 1. Good, good. But this is good. This is also good. But why this is not good is because of this. Why I'm getting minus 1? Wait, I'm starting with this. Okay. 0 is connected with 1. 1 is connected with 2. So it's like this. 0 is connected with 1. 1 is connected with 2. Wait. And 0 is connected with 2. Right. So we reach actually. What we can do is can debug this nicely. We can do here is person X what is out X. Let me see. Got it. So what is just happened here is wait a minute. So we at U. Okay, so I have pushed this 0, right? 0, 1. Okay, I pushed this. Now this is my U and here. Okay. Got it. Visit of V is equal to 1. That's fine, but why? Let me also put its child. So from 0, we saw here, right? From 0, we can go to 1 also. From 0, we can go to 2 also. From 1, we can go to 2. So let's see what it does. Wait a minute. Here. Now this is fine. I'm terrible at problem solving and maths. Can you give me some tips to improve? I know it's about practicing and understanding the patterns by solving problems. Still, can you tell me how can I try? What you can do is just first try to figure out, like, if you want to improve in maths, try solving writing wise. You can follow tags. Tags is not that much useful because I tried. You have to get some list of questions based on the topic. Let's say you want to practice a modular arithmetic things, right? Just get the list of the question which has the modular arithmetic concept used vastly in this and solve the difficulty wise. Like, for example, say if I take the reference of code forces, just try solving 800. If you able to pretty much confident, if you feel confident, then move to 900, then move to 1000. This is how you can evaluate yourself and increase your rating. Like, this how you can practice. Actually, you need something, right? You can, okay, so here we can visit one and two, but what the thing is, one is not visited, and the new weight is also less than this, and the current count. Yeah, it is fine, right? Current count can be two here, so it won't go to one, but it should go to two, right? I think I have to debug that also. See out current count. Yeah, so in short, if I can say how you can start is start topic wise, not just random practice, and solve the question based on the difficulty level from lowest to highest. Just aim for if you're totally new, then aim for 1200, for 1800 to 1200. If you're able to solve the questions of 1800 to 1200 for a particular topic, then you can say you are pretty good at that topic at initial level. New weight, right? Okay. Let's see what the fuck is going on here. Okay, so we have one. Current count is two, so will not traverse two. So will not go from one to two because of this condition. That's fine. Now this is this. New weight is this. Why? 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 What the fuck is this? It is not same, right? Label of V is equal to label of U. No, it's not same. So why it's increased here? Fuck. No, don't tell me I have to. This is extreme debugging. L1, this is fine. Unless and until you're not feeling bored. L2 is this. So this is the beauty. If you start writing your own code, you will never feel bored while debugging. See, this is 1 and 0, right? Alam, A and B. Don't tell me. I have to put one more string statement here. Old count. Old count is 1, right? And these are not same. It should 1. But why it is giving 2? That I'm not sure here. We can do is we can print here. And this is new count. Start writing your own code and debug. The limit you can. See, old count is 2. This is not good. Why the old count is 2 here? See, if we take this, got see. This is interesting. So we are at 0. The parent is this. Let me just bring. If you're debugging, then let me debug it extreme. See, we'll see everything in our log. We are at 0. Now we have to explore its child, 1 or 2. So see, we are at 0. So we first explore 1. So we are trying to explore 1, and what we see is old count is 1 because this is A. We have 1A, right? Till now. Till now we have 1A because we got from here. The information we get from here. And the new weight is also 1. Okay. And the new count is 2 because this is also A. And if I include this, then it becomes 2A. That means consecutive identical character become 2, which is not allowed here. They're saying only you can take one consecutive. That's fine. So that's why, I see. Okay. This. That's why I have to declare this variable inside. Wow. This is the what because what it does is we are discarded this, right? So next time it will go here and it should take 1, but because I have declared this variable outside, so it retain its value 2 and become 3. So yeah, so here we get 3 is our answer. Here also we get 3. How 3? Now they allowed 2. See, they allowed 2, right? Hmm. This is fine. Let's debug here. So here at 0, okay. If we are trying to move from 0 to 1, then both is then new count is 2. Okay, we are good to go with this. And if we go here, then new count is 1. Okay, we are still good to go, and we are at here. Now we want to explore this one's children. There is only one children, that is 2. So parent is 1. So we have explored 2. This is A, this is B. Then wait. Huh. It is already because we are moving this way, right? We already moved here. Already there is two consecutive character. Okay, got it. We have to retain actually. We have to retain. If it is different, yeah. If it is different, what we can do here is see. If it is same, will increase. If it is different, this is equal to 1. Think this is fine. No. Why? We are at 1, A and B. New count is 1. Okay. What is our new weight? Is 2. Yeah, new weight is 2. New weight is 2, right? And new current count is also 1 here. That is also good. Then what's the issue now? We are at 1. This. Then we have to enter here, right? We have to enter here. Did we enter? No, we haven't entered. See, why we haven't entered? We are at 1. Now we have to explore 2. Yeah, both is this. It's not visited earlier, or it is. We don't need visited then. Wait. We don't need visited thing. That's what I confused earlier. Cool. This is fine, right? But I'm hoping it should not give a TLE. It will not give TLE, right? Because we have already a check here. If we find something better, we definitely travels. Let's see. Let me remove all the comments. Yeah. Let me submit. Let me give me a try to submit. And we have a wrong answer. Cool. So we had a wrong answer. Fuck. Only one wrong answer. I already passed 998 out of 999. Why? I fail only one test case. What's the issue? We don't need this visited things. Fuck, I passed 998 out of 999. This could pass 998 test cases out of 999. What I am missing then? The fuck is this? Almost done. 99% it's done. Uh, this is a usual dice draw, right? Hmm. I'm getting 550, but answer is 527. Why one test case? What the hell? Wait, wait, wait. What I'm missing? It failed one test case, right? Out of all the test cases. Why? Why it just happened? Mhm. Okay, we'll maintain here the distance from 0 to IF node. Okay. Hmm. Current count is this. This is our new child. If the label match, the count will increase. Okay. Otherwise, count become reset. It's a new character, right? Yes, that's fine. Or we can add this. Yeah, maybe. Okay, yeah, this is what I miss. I think this is what I miss equal to. Oh my God. Then it is TL. No, equal to is not because if we already equal, that means we already visited, right? Yeah, equal to is why I'm not putting why I initially not put equal to is because if the distance is let's say from some else path I'm getting X weight here. From here also I'm getting that means in previously if I at this point and my weight is X, then definitely I have explored all the paths, right? Why one test it's failed? This is the new distance. Yes, in the current count. What am I missing here? Oh, wait a minute. I need to put everything long, long. Is that the case? U, W, and count. Child. No, right? Why it failed one? I'm not getting it. Wait a minute. Should I? It's the mind. It's not logical bug. Definitely, it's not a logical bug because wait a minute. This is a parent. Okay, so we have to explore its child. Okay. Hmm. And V and W. That's fine. Okay. This is a new weight. If new weight is the better weight for this children, then we'll continue to explore the children. Hmm. What is the edge case and edge case we are missing? Let me add the text also. How we can add text? I want to add text. Yeah, update, latest update. Current send pass. Yeah, okay. Let me decrease its width. Uh, Wait a minute, where it went. Yeah, this is good, right? What is that one test case? We can do is this. If W is greater than mm, this is a redundant text, right? Uh, this is also fine. Let me just submit out. This will also pass 919. It's a optimization because if see if it current weight if the parent weight itself is so adding it's definitely make you bigger, right? Say it pass 998. Why one test case? Why it's failing one test case? Do anyone have idea in chat? Why it's failing one? Uh, this is fine. Here we are adding both the checks. Otherwise, it's a normal Dijkstra algorithm, right? Or we should not waste time and give ChatGPT tell what we are missing. Or we should think. Just let me know. Guys, if anyone in the comment, let me know. Are we okay to debug? Or we just take the help? Almost pass, right? It almost pass. I'm not getting that kick. I want to see accepted. It failed one test case, right? Uh, do anyone want to know what I'm trying to do here? Or did you guys already know like what I have coded here? I just want to know what's the bug in this code that why it doesn't pass the last test case. Hmm, let me think then. At most K, right? That means the total identical character we can take consecutively, it should be K. Okay. Yeah, it's fine. This is okay. Yeah, this looks too okay to me. This looks okay to me. Wait a minute. We should not waste much here. There's something I'm missing. Well, I don't want to use AI here. What I'm missing? Why it failed one test case? See, if usually what happened when in such scenario, something is out of bound, something is like out of range. These are the things usually you can do is what I'm missing here. It pass. Okay, okay. So it's saying कि you should maintain. We can treating diaster state only on node, while the actual state is the single node loses necessary information and cause exactly the kind of hidden test. No, what the fuck is telling me? Yeah, got it. So what we are doing is here we are storing the information only on the node. So the point we are missing here is, let's say you have reached a point X with three consecutive character, and let's say from some other path you reach the node X with two consecutive character, and you still have to take one extra. The limit is K, right? Case K, and you have here case 3. So if you come from this path and you have Y cost, and you came from this path also, and it's also has a Y cost. So in my case, it will not explore this because cost is same, and we Here we have put in this condition. Cost is this. So here itself it's fail, right? So it won't even check this. Yeah, got it, got it. Good insight. Good, good, good. We can see some nice solution then. How other people have what this person did is see. Uh, it's maintain node versus k, right? Yes. So that's all. What we have to do instead of what we are maintaining here is this. We are only maintaining on the base of node. So we just need to update this vector of vector n comma vector of k plus 1 comma 1 18 cool 0 0 okay then count and these things we have to put first. Yeah, and here we need to do this and this. I hope this is what. Ah, here we have to do this, not this. Actually, it's current count and where? Yeah, here. Actually, we don't need this for now. So it is asking what the fuck is this K? Yes, that's true. Vector of int K plus 1, comma 1 each. You're saying what the fuck you're doing in the form of error. Good, 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 good. Then why this is failing now? Why this is failing now? Okay, okay, I got it, got it. What we can do is we can do like this. Cool. But why it's failing then? Why it is failing at last test case 0, right? Ah, I see, I see. I have to maintain int I is equal to 0, I is less than and I plus plus straw of I comma 0 is equal to 0. Why it is failing the last test case? It started with 0, right? Why it is failing the last test case then? I is equal to 0 in the case. This is impossible, right? I have to do instead of this distance of 0 comma 1 is 0. Why it is failing the last test cases? Okay. We are maintaining N and K, right? This is our, I can say, we can use this also. Current. If label matches, we increase. Let's see how other people did. It's fine actually. It's no, it's a DFS. Yeah, this is what I'm doing. If distance is greater, we are continuing. Otherwise, okay. Yeah, this is what I'm missing. So we have to actually take one E8 chain from INTI is equal to 0, I is less than equal to K, I plus plus. Answer is equal to minimum of answer, comma, dis of n minus 1, comma, I. And if answer is equal to 1E8 chain, then return minus 1. Otherwise, we have to return answer. What the fuck? I am done now. This is what I maximum I can debug. What the hell is happening here? I don't know. What I'm getting is 556. I have to tell ChatGPT to debug. What's the mistake I am doing? You fix the main issue, but the same bug. You forgot to reset count. Fuck, right. Else, current. So if we start with different character, then we have to reset the count is equal to 1. Yes. 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 Got it. Let me submit. Yes, we got AC. Now we don't need this. Ooh, ooh. Okay, cool. So we have solved this question. Should I try this? Let me just update actually. We haven't solved an add water question, right? Save. One question is enough. We have learned a lot of things because what we are missing here is, we are not even storing the, what we miss here is information because we are storing only n. We have to store n and k. That is the good observation I have missed here. That's why I failed one last test case. That's a good question and good learning also. I think let me try this also. Should I try this? This is easy and I'm not gonna try this. Maybe some brute force will work here. Most probably, yeah. We can try this medium question. Yeah, let me try this. Minimum light to illuminate illuminate a road. Okay. You're given an integer array lights of length n representing position 0 to n minus 1 on the road for each position I. If, wait a minute, for each position I, if light of I is equal to V, if V is greater than 0, there is a working bulb at position I that illuminate every position from, okay, so it actually in a pairing, so let's say this is the light lamp and it has a V brightness, so it will bright the left V side and right V side, this distance. The total it's a 2V distance it will from left V and in right side. If zero, then not working well, it's fine. A position is visible if it is illuminate at least one light. Okay, you may install additional bulb. You may install additional bulb at any position. Each additional bulb installation at position J illuminates position from this to this. Okay. Any position, let's say the position is J. Return the minimum number of additional bulb required to make every position on the road visible. Okay. So what it is trying to say is let J, right? J plus 1 and J minus 1. Let's say I'm installed at 3. Uh, okay. 0, 1, 2, 3, 4, 5, 6, 7. What I'm thinking is if something is invisible, we just need to insert one additional bulb and work is done. What I'm thinking is, let's say if I'm install a additional bulb at 4, so according to this statement, 0, comma 3, that is 3, and here n minus 1, that is 7, comma j plus 1, that is 4, 5. Every additional bulb installed at position j illuminate the position from this to this. So 5. Ah, I see. Okay, so that means they're trying to say is additional bulb has a brightness of 1. It is pretty confusing if you not use pen and paper. No, for it's not necessary. For most of the people, it's simple. For me, it's actually confusing. That's why I have to visualize the thing. Okay, so what I'm thinking is with the initial setup, we'll see how many positions are visible and how many positions are not invisible, I can say. So with one bulb, we can actually make three consecutive places visible. Right? Yes. 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 What are the constraints? Constraints pretty high. I love, we want something in order of n or n log n. So what I'm thinking is some kind of difference array and thought. So for each bulb of V brightness, what I will do is I will do plus one. I'm just marking the position. Yes. Hmm. Mhm. Yeah, you can use some kind of difference array here. N is equal to lights dot size. Okay. Then what we'll do is for int I is equal to 0, I is less than n, I plus plus. and let me call a vector a difference array. It's a nice concept, difference array. Like you can tell the final state. For example, say you have an array and you have a q queries in the form of range. L, like each query has two integer L and R, and you have to do plus X to the entire range. After performing the Q query, you have to tell how the final array look like. So this is a very good example use case of difference array. You can look this concept n comma 0. Okay, so int v is this the brightness, and using this brightness I can calculate the from where to where I will calculate my range. So what I'm doing is this is my initial array that is called difference array. For example, say light I, I'll calculate L and R. Let's say this region. So I will mark everyone one here. So how we can do using difference arrays like this? Maximum of 0 comma I minus V, and R is equal to minimum of n minus 1 comma I plus V. Okay, so what we'll do is let me declare this. Yeah, so difference of L plus 1 and difference of R plus 1 minus equal to 1. So this is how we'll perform the query. Cool. Hmm. Now we have to calculate how many additional new bulb we want. Is this, and we have maintain a previous is equal to minus. Previous is equal to let's say 0, because one additional bulb can bright up. Let's say I have inserted one. It will bright this and this. Uh, 0, minus 1, minus 2, and this is minus 3. Let me store the previous as minus 3. Yeah, for int I is equal to 0, I is less than n, I plus plus. And for the difference array equal to 1, I is less than equal to n, I plus plus. Difference of I plus is equal to difference of I minus 1. Yeah. So what we have to do is if difference of I is equal to 0, that is, it is invisible position. You have to check if previous, yeah, previous is minus 3, right? So current is I minus previous is less than equal to 2. Then we'll continue. Otherwise, what we'll do here is previous is equal to I and answer plus plus. Return answer. Will debug, it's fine. So what happened here? We have to insert this one bulb here and one bulb here. Yeah, this is what I'm also expecting, right? But my code didn't. So what we'll do is we'll check the difference array first. According to me, also it should give 2. So the best whenever you'll code yourself a code and say this is not good, right? What just happened here is if v is equal to 0, then I minus. Yeah, if v is equal to 0, then continue. Cool. See, got it, right? Then submit, and we got accepted. Cool. Now we left with one medium question. I think I should give a try to this and then we can end up the stream. Okay, it's another graph question. Finish time of task one. Oh, if this task one, then it's a once, and maybe in later contest we'll get. So how many questions we solved right now? We solved two medium question, right? Solve. Maybe there might be a spelling mistake. I haven't saw what I typed. Yeah, this is the last question. Then we can end up stream. Hopefully, I'm able to solve this question. Trying. Yeah, I got it. Now there's no spelling mistake, I think. Yeah. So the what question is saying earliest time of task, finish time of task, sorry. So you are given an integer n representing a number of tasks in the project's number from 0 to n minus 1. These tasks are connected, has a tree rooted at task 0. Okay, it is representing like this, where we know this is the edge. So this is a tree. You're also given a base time of length n, where base I represent the time to complete a task I. The finish time of each task is calculated as follow. Okay. Leaf task. Finish the finish time is this. Okay. Non-leaf task. The earliest to the minimum finish among its child and latest to the max. Oh, wait. The earliest non-list task के लिए क्या होगा? Let earliest be the minimum and the latest be the maximum. Let on duration is this, and finished task is latest plus on duration. Okay. Return the finished task of root node. So we have to move from bottom to up, and we have to return the finished task of node zero. Got it. So what we have to do, we have to recursively calculate. Hmm. Right. We have to recursively calculate the finished task. And we have to maintain the minimum and the maximum among its children. For each node, we have to maintain a minimum and maximum time. Yeah, we have to write a good recursive solution. That's all for this question is asking. So we can do is for the root node, we have to find our answer, right? So once recursion is returning, we have to update the mean and maximum among its all children. Yeah, I have to write a good recursive solution. Yeah, this will test my recursive skills. It's a long time. So let me declare long answer is equal to 0. I think what we can do here is Hmm. We have to calculate the adjacency list. That will tell you what are my children's. What are my the chil what are the children's of ith node? Okay. Then I have to calculate answer for all its children. Then I have to maintain the minimum of all the children, and I have to maintain the maximum of all the children. Yeah, that is what we have to do. Okay, okay, okay. So it means we have to move level wise. Yes. This is the third question of bi-weekly. It's a third question, third bi-weekly. We have to move level wise, right? Thanks, who's ever giving me heart. Wait a minute. Hmm, thanks. See, what you have to do is you have to call its recursive. Yeah, I can make a call here then. For the each parent, we have to calculate for each parent we have to know the its children finish task. Then among all its children, we have to calculate its minimum, then maximum. Yeah, that's it. So solve. Let's say return solve. Parent is 0, and I have to calculate the existence list here. Vector of vector in list of n for auto m person x over edges. It's a tree, right? It's a tree, okay. So it's a third question. Let me give you the link in. Hey man, how are you? It is third question of bi-weekly. I think it's a bi-weekly, right? Yeah, bi-weekly. Yep. So what I'm thinking right now is, do we need? We'll figure it out in the fly. If you need a visit factor auto x, then we have v is equal to x of 0, then we have v is equal to x of 1, and then we can say v dot v x v, and for u. Okay, so yeah, we'll pass the exponential list here. And do we need to pass min max? Uh, no, right? Now we'll create a recursive function for this. This is the node, and this is its exponential list. Cool. So yeah, for now here, what we have to do is find max finish time. among its child. Node is the parent. Then we have to find mean. I think I need a spelling mistake. Ah, finish time among its child, and then we have to return return this. Got it, right? Let's on time is this latest minus earliest. Wait, if I expand this equation, what I'll get is if I substitute this on with the latest, I will get this thing, right? So it's like the two times latest minus earliest plus base time. Yeah, this is what we have to return. Okay, then pass this thing. We need this also. Base time. Fine. Yeah, got it, right? So what we'll do here is we need to maintain a visited or not. That I'm confused here. Actually, we don't need visited vector because it's a tree, right? Tree don't tree does not have a cycle. That's the definition of tree. Let's make a tree and graph. A common differentiation is tree doesn't have a cycle. And why we keep visited vector to reduce the infinite loop, right? So for now, let's not uh, create a visited vector. What we'll do is its child will iterate to its children. Now we need for its children also, and yeah, if it is leaf node, how we can identify if it is a leaf node? If it is a leaf node, what we can tell is existence list of nodes dot size is zero. That means it's a leaf node. So in this case, we have to return base time of node. Yeah. Now it is not a leaf node, then we have to maintain mean, a latest and the earliest. Earliest and later. Earliest is the minimum, right? So I'll store with 1 is 18 and long. What's the earliest? Wait, yeah. Earliest is the minimum. Here I have to, and here I have to store minus. Yeah. So for each child, we'll calculate similar thing. So okay. If it is leaf node, then this is the answer. Else. For its children, we have to calculate this thing. What we'll do is solve for child, right, with this identity list and with this base time. Let's say finish finish task time, and we'll maintain this latest is equal to max of latest comma this earliest is equal to minimum of earliest comma this. Yeah. Then we'll return. What will return this. Latest plus on duration. Let's on duration will be latest minus this. So we'll return 2 into latest minus earliest plus. This does not seem too reasonable, right? This thing is not. I'm still worried about this thing. This doesn't feel me a reasonable. Part is still connected, right? Yeah. Let's try. We'll debug then. No. Okay. See, we miss here something. That is this. So we have end up in an infinite loop. I guess we started with zero, okay? Because for zero we want to find out what is the finish time for root node. So zero is our root node, okay? So what I did is, if it is a leaf node, then we have to return base time. That is what we mentioned here. Yeah. If it is not a leaf node, then we have to iterate with all children and get the finish time. Let me reiterate this statement. On duration is just the latest minus earliest plus base time. The finish time of task I is latest plus on time. How this makes sense? Yeah, this is what. Yeah, then we are. This is fine. So this conversion we did, that is good. So that is what they want us to make. This is just two into latest minus earliest plus base time. But now we have to check why it's ran into an infinite loop. Wait, it is infinite, right? Yeah, Stack Overflow. Okay. Let's say if I'm at zero, the children is this. And for this, it will eventually find for this, right? And then it will return here. It doesn't have any other children. Okay. Yeah, this is fine. It doesn't have another children here. Yeah, this looks good to me. Wait, let me debug. And what we are returning out finish time. If this okay. All we can do this. Just want to know like why it is into an infinite loop. Okay, okay. So what we can do is do not make bidirectional. See, I told you, right? Tree is not a bidirectional. It is bidirectional. We can move. We can treat as a this thing and this thing. Let me submit. Yes. And we got accepted. So yeah, let me update the tab. So let me update all Hungarian system. Anything else you guys want me to try or approach you want to know what I followed here, how we get an accepted label. It is a good recursion question, by the way. Anyone, if anyone has any doubt, can ask. We'll wait for more 5 minutes. If there's no doubt, we'll end up this time. Should we go to the hard questions? I don't think so. Yeah, we solved this also, right? Yeah, I don't have energy for the hard question now. So that's all for today. This, this is the update test. Text solved. That's all for today. Thanks everyone for joining.